So these will be the homework questions that you guys had in class. Some of them, if they look similar, I may skip, but we'll start off with number 22. So this, I think they just asked to find the derivative at that point. And so what I need you to understand is if they're asking you to find the derivative at the point, the answer is not going to be a function or a relation. It's actually just a number. So what you're going to notice is I'm going to take the derivative of each term. So this is 2x. Here, I'm going to actually change this to plus negative 3x, root 3x times y. So I'll do a product rule right there. So plus negative root 3x, and that root ends at the 3, times the derivative of y with respect to x, plus y times the derivative of negative root 3x, which is negative root 3. Alright, so that's just the product rule right there. That is a negative root 3. And then we got 4y dy dx equals 0. And I'm not even going to bother simplifying it because now I'm going to substitute in root 3 comma 2. So I get 2 times root 3. This term I'll just turn to negative root 3 times root 3 dy dx because I don't know that value, plus the y value of 2 times negative root 3 plus 4 times 2 dy dx equals 0. So the reason I'm able to do this because I don't want to simplify to make an equation, I just need to find a value. And when you're asked to find a value, it's actually a waste of time to try to simplify down to a nice equation because you just need a number. And simplifying, remember, it does a makeover. Still the same equation, just looks different. So here we go. We get 2 root 3 minus 3 dy dx minus 2 root 3 plus 8 dy dx equals, oopsie, 0. So 2 root 3 minus 2 root 3, and then really I still get 5 dy dx equals 0. So dy dx, hopefully for 22, equals 0. Now I believe the question was to write the equation of the tangent line and then the normal. So A, the tangent line has a slope of 0. If it's a slope of 0, that means it's a horizontal line. And all horizontal lines have the same equation, y equals. So the answer to A is y equal to 2. And if I'm going to make a normal line to that, then it's a vertical line. All vertical lines have the same equation. They're all the x equals. So those are the answers to the question. All right. Next question, 24. So same thing for this guy. I'm going to find the equation of the tangent lines. So start off with a product rule. Leave the first one times the derivative of the second, and this is a chain rule, so cosine. Derivative of the outside, leave the inside exactly the same, times the derivative of the inside, which is 2 dy dx. Plus, I guess I could close that there. Plus, leave the second term the same, times the derivative of the first term, which would be 1, equals, and again, another product rule with a chain inside, so leave the first term alone, times the derivative of the second, negative sign of 2x multiplied by the derivative of the inside 2 plus cosine, of 2x times the derivative of the first term, which would be dy dx. And exactly the same thing I'm going to put in for my x pi over 4 and for my y pi over 2. And I'm actually going to do that in this step now. So my x is pi over 4 times the cosine of pi times 2 times dy dx plus the sine of pi. That's because it's 2 times pi over 2 equals the y value, which is pi over 2, times negative sine of 2x, so that would be pi over 2, then times 2, plus the cosine of pi over 2 times dy dx. And then I'm just going to find all my values. So in this case, cosine of pi would be -1, so pi over 4 times -1 times 2 times dy dx. Sine of pi would be 0. See? And on the other side we have pi over 2 times negative sine of pi over 2. That'd be 1 times 2 plus the cosine of pi over 2 would be 0 dy dx. So that term cancels and we end up with dy dx times all of this, which would be negative pi over 2 is equal to negative pi, and then dy dx is equal to, so I would divide by this, which would be multiplied by 2 over pi, so I get 2. Oopsie. Wow. Alright, so for 24, I would get the equation of the tangent line would be y minus y over pi over 2 is equal to 2 times x minus pi over 4. And then the normal line, y minus pi over 2 is equal to -1/2 times x minus pi over 4. Okay. I think last for number 28. So find dy dx and then the second derivative. So 2/3 x to the -1/3 plus 2/3 y to the -1/3 times dy dx is equal to 0. So what do we get? We get that dy dx would be equal to, first I'm going to move this term over, and then I'm going to divide by the coefficient. Actually, I feel like I should show that step. So let me bring this back down. And then dy dx would be equal to -2/3 x to the -1/3 divided by 2/3 y to the -1/3. So I believe my dy dx would be negative, and I could write it two different ways. I could write it as negative x to the 1/3 over y to the 1/3, or I could do negative x over y to the 1/3. I don't really care which one you decide. Then they're asked to find the second derivative. Alright, so now I'm going to do the second derivative. So we'll need this piece right here. I'm trying to think which derivative I'll use. Alright, so I think I will use what you probably would have used. I'm guessing this one. So my second derivative would be to take the derivative of the left side, which gives you this funny looking term. That's just the derivative of dy dx. And then this one, I think I'll do low d high. And I'm going to move the negative to be with the x term so that we don't have that floating in the front either. Alright, low d of high. Oh wait, was that -1/3? Oh, oopsie. Sorry guys, back it up a little bit. That was a -1/3, that was a -1/3. So if I have -1/3, real quick, I would have negative, and if I want to make them positive, that's what I want to do. This negative term would move to the top to make a positive exponent, and this negative term would move to the bottom to make a positive exponent. Therefore, the other answer is actually this. Sorry, guys. Alright, but with that being said, let me fix what we got here. So this would have to be y over x. But same as before, I'm actually going to use what we have here. And so remember, say that negative in front, I moved it to the x term. So I want to actually use negative y to the 1/3. I want my powers to be positive, that's why. That's all. I don't really care if you decide not to do it this way and you want to use the negative exponents, that's fine too. Alright, so low, d of high, so negative 1/3 y to the negative 2/3, oopsie, dy dx, minus high, which would be negative, so I'm going to turn that to a plus, d of low, 1/3 x to the negative 2/3. See? Come on. All over low. Oh, sorry guys, I'm confusing myself because the low should be, I should be using this term. So low, d of high, minus high, d of low, all over low, squared. So, remember the dy dx, we got to put in what we already had, so x to the 1/3 times negative 1/3 y to the negative 2/3, oh Lord, times negative y to the 1/3 over x to the 1/3 plus 1/3 y to the 1/3 x to the negative 2/3 all over x to the 2/3. So let's try and get rid of all these weird negative exponents to clean it up, and I'm going to move everything to up and downstairs. So this whole term right here, it's one big term being multiplied, so I'm going to put it all together. The numerators, let's see, in the numerator I would have x to the 1/3, took care of this. I would have this piece here times negative y to the 1/3, took care of that there. This negative 1/3, I will put another negative here for the negative. The 3 goes on bottom. The y to the negative 2/3 I can bring downstairs to y to the positive 2/3, and downstairs was already an x to the 1/3. Yes, there's other ways to do this. Plus, it looks like y to the 1/3 is in the numerator, 3x to the 2/3 is in the denominator. That whole thing will be divided by x to the 2/3. Alright, so it looks like to make the common term, I got to multiply this by y to the 2/3 over y to the 2/3, and I have to multiply this one by x to the 1/3 over x to the 1/3. Alright. So we end up with, and I don't think that's part of it. So we get that this becomes positive, and these x's together make x to the 2/3. I still have y to the 1/3. These together make y, and in the denominator I end up with 3y to the 2/3 times x to the 2/3 times 1 over x to the 2/3, which gives me x to the 2/3, y to the 1/3, plus y, all over 3y to the 2/3, x to the 4/3. I could factor out, probably divide all of them by y to the 1/3. And what that would look like is x to the 2/3 plus, if I divided this by 1/3, I would be left with y to the 2/3 in the numerator, all over 3x to the 4/3. Let's hope I'm right here. I don't even know what number I'm on anymore. Now, if you remember, hopefully I did this right, I think the original equation was x to the 2/3 plus y to the 2/3, which is this guy, so this should equal, oh actually, I forgot one thing, this guy still has y to the 1/3 left. But remember the beginning, x to the 2/3 plus y to the 2/3 equals 1. Therefore, the numerator is 1, and the denominator is this guy. Interesting question. It's kind of nice how easily it worked out. Easily probably isn't the best word. How simplified it became. 49. Find 2 points where it crosses the x-axis. So crossing the x-axis, those are called x-intercepts. X-intercepts occur when y is equal to 0. So that's all that says. And show that the tangents means derivative. I'm going to find dy dx. To the curve at these points are parallel. Parallel mean that the tangents have to have the same slope. So that's how I break apart a question. So if I had no idea, because this is not a problem you've seen before, that's how I would break it apart. So to start off, I think I will find the 2 points, because that's where it started. So I'm going to set y equal to 0. So x squared is equal to 7. So x is equal to the plus or minus root of 7. Interesting. Alright, next I'm going to find the derivative. So 2x plus, let's do a product, x times dy dx plus y times 1 plus 2y dy dx equals 0. So dy dx terms, I'm going to actually factor this out. I have the x here, I have the 2y here, and on the other side I'll move the 2x over, and I'll move the y over. Therefore dy dx has to equal negative 2x minus y all over x plus 2y. So that's going to give me the tangent slopes, and I want to find them when I think the points are positive root 7, comma 0, and then negative root 7, comma 0. So let's do this one over this side. So the derivative at root of 7, comma 0 would equal negative 2 root of 7 over root of 7, which gives you negative 2 for that one. This one, I would have positive root of 7 over, positive 2 root 7 over negative root of 7, which equals, forgot the negative there, negative 2. Parallel means same slope. Those are the same slope of negative 2. For the last part they asked you what is that common slope. So it's negative 2. 50. I want to find tangents that are parallel to the x-axis. So the x-axis, if I want to be parallel, I need a tangent who has the same slope as the x-axis. And the same slope means that the slope has to be 0. So really they're asking you to find the horizontal tangents. So part A, horizontal tangent, take the derivative, so that's the first part, 2x plus, positive, product rule, x dy dx plus y times 1 plus 2y dy dx equals 0. Dy dx Factor it out from the common terms, which are x plus 2y. Move the other terms over. I get negative 2x minus y dy dx is equal to negative 2x minus y over x plus 2y. So if I want horizontal tangents, I want this fraction equal to 0. The only way that can happen is negative 2x minus y equals 0. So negative 2x is equal to y. Two variables. Can't solve it. So if there's two variables in this type of problem, I got to substitute it back into the equation. If you try to substitute it back into the derivative, you'll just end up with something that can't be solved again. So that kind of gives you a hint that you put it into the wrong equation. So I have x squared plus x times y plus y squared equals 7. So what do we get? We get x squared minus 2x squared plus 4x squared equals 7. So we get 4 minus 2, which is 2. 2 plus 1 makes 3. So 3x squared equals 7. X is equal to plus or minus the square root of 7 over 3. And what it asked me to do was find the points. So if x is the root of 7, positive root of 7/3, then the y value would be negative 2 root of 7/3. And then if the x value is negative root of 7/3, then the y value is positive 2 root of 7/3. Alright, the next piece asks you to find where it's parallel to the y-axis. Now the y-axis goes up and down, so that means when the slopes are undefined. To be parallel to an undefined slope, it also has to have that same slope. So, in this case, we're going to take this derivative that we found a second ago, and I want to make it equal to undefined instead. The way we can make it undefined is setting the denominator equal to 0. So x is equal to negative 2y. I'm going to go back and steal the original equation, which is this guy, which I'll put right here because I'm going to need it. Oopsie. Okay. So x is equal to negative 2y, so there's negative 2y squared plus x again, which is negative 2y, times y plus y squared equals 7. And so we get 4y squared minus 2y squared plus y squared equals 7. And we get 3y squared is equal to 7. Y is equal to plus or minus the square root of 7/3. Therefore, if I use this equation for my x, I get negative 2 root 7/3 when the y is root 7/3, and then I get positive 2 root 7/3 when my y is negative root 7/3. Okay? Number 55. Find the slope at those 2 points. At what point other than the origin does it have a horizontal tangent? So you're going to take this, find the derivative, set it equal to 0. Here, we're going to find the derivative and set it equal to undefined. Alright, so there are all the pieces. Find the slope at those points. So let's start off with part A, 3x squared plus 3y squared dy dx. Product rule between negative 9x times y, so plus negative 9x times dy dx plus y times negative 9, all equals 0. You want to find the derivatives at, and in this case, just because I'm finding it at 2 different points, and because in part B and C I'm going to need the equation of the derivative, I'm actually going to solve for the derivative and simplify it. So this term and this term have the dy dx, so I'm going to factor that out from 3y squared minus 9x. The other 2 terms, this guy and this guy, I'm going to move to the right side of the equation, so it's negative 3x squared plus 9y. Therefore dy dx is equal to negative 3x squared plus 9y over 3y squared minus 9x. Alright, so I'm assuming at this point you could substitute in the points and get the derivatives. I will do one of the two, not both. I'll do part B, which asked you for the horizontal tangent. So I'll take this equation and paste that. So here's the derivative. If I want a horizontal tangent, set it equal to 0. Only way this could be equal to 0 is if the numerator equals 0. You have a choice in terms of what to solve for. The better term to solve for is your y, because then you won't have a plus or minus square root. So if any term is a linear term, meaning power of 1, that's actually what you want to solve for. So 9y is equal to positive 3x squared. So y is equal to 1/3 x squared. Then I'm also going to need the original equation so that I can substitute it in. How did I know I would need to do that? Because there are two variables. So I know I can't solve it. So there is my original function. Let's go right underneath there and put x cubed, see, x cubed plus, so if I did this right, y cubed, which would be 1/3 x squared cubed minus 9x times y squared equals 0. Good Lord. Alright, so x cubed plus 1/27 x to the 6 minus 9 over 3, so that's 3 x to the 3rd equals 0. So 1/27 x to the 6 minus 2x cubed equals 0. X cubed factors out. 1/27 x cubed minus 2 equals 0. This gives me x equal to 0. This gives me x cubed is equal to 54. X is equal to the cube root of 54, which I believe is how I'm going to leave it. At what point other than the origin? So there's my x value. My y value would be 1/3 x squared, so that would actually be 54 to the 2/3. Alright, so I'm not going to do part C because I'm pretty sure it's almost exactly the same as part B. I'm actually going to just check my answer and make sure if we're doing, what number am I on? Hopefully I didn't make a mistake, that would suck. 55B, that is not the answer that the book gives. 3√8, so let me just make sure. Yep, that is the same answer as the book. So your x is equal to the cube root of 54. 54 is the same thing as 9 times 6, which is the same as 3 times 3, which is 3 times 2. It takes 3 of them to come out of a cube root, so it's 3 cube root of 2. FYI. Alright, so I'm not going to do part C, very similar. And then 57, find the normals to the curve that are parallel to. So we see the word parallel, which means I got to find the slope of this line. Y is equal to negative 2x. The slope is negative 2. What's the other way you could have done it? You could have found y prime, and that is negative 2. You want the normal to be parallel, so that would mean there's two different ways to do it. You can find the normal of this and make the derivative equal to it, or you can do the negative reciprocal of the derivative and make it equal to negative 2. So first of all, let's actually find the derivative. And I'll show you the two different equations you could solve. Alright, so xy, so x dy dx plus y times 1, that's the product rule, plus 2 minus dy dx is equal to 0. Factor out the dy dx from the terms that have it. X minus 1. Move over the terms that don't have it. Negative y minus 2. And therefore the derivative is equal to negative y minus 2 all over x minus 1. So, again, what I said was either you can set the derivative equal to the opposite reciprocal of the line, or the normal of the curve would actually be the opposite reciprocal of this guy. So you would have to flip the fraction and make it negative. Oopsie. Looks ugly. And then that you would set equal to the regular slope of that line, which is negative 2. Those actually are exactly the same thing. Now, how do you deal with this negative? You give it to the numerator or the denominator, but not both. Because these are both negative, I'm going to prefer to give it to the denominator. So the equation I would have solved for would be x minus 1 over y plus 2 is equal to negative 2. There's two variables, so you'll end up having to substitute back into the original. Two variables, you substitute back into the original. So, let's see what we get here. Let me steal this guy. And I'm going to steal the original equation. That's this guy. Clipboard, move over. Okay. Come on. Paste that here. So there we go. So x minus 1 is equal to negative, I'm going to multiply by y plus 2, negative 2y minus 4. So x is equal to negative 2y minus 3. So then I would substitute that back into the original. So x, negative 2y minus 3 times y plus 2 times x, negative 2y minus 3 minus y is equal to 0. I get negative 2y squared minus 3y minus 4y minus 6 minus y equals 0. See what we end up with. Negative 2y squared, negative 7, negative 8y minus 6 equals 0. Divide both sides by negative 2. Negative 2, negative 2. Therefore, y plus 3, y minus 1, oh sorry, plus 1 I meant, equals 0. So y is equal to negative 3. Y is equal to negative 1. Use this again to find my x value. So x is equal to, if I use y equal to negative 3, 6 minus 3 is 3, and then that's x1. x2 would be, if I use y equal to negative 1, negative 2 times negative 1 minus 3, and that gives you 2 minus 3 is negative 1. Therefore, it's 3 comma negative 3, and then negative 1 comma negative 1. And again, that's if I have no mistakes, and hopefully I do not. That does look like the correct answer. There you go.